Hey everybody, thanks for tuning in today. Today we're going to look at the surface area of pyramids and cones, section 10.3 in our curriculum. So last time we looked at the surface area of prisms and cylinders. Today we're going to look at pyramids and cones. To start with pyramids, let's start with the basic parts of a pyramid that everybody should know. All right, first of all, the top point, all up here where all the lines meet at the top, that's simply called our vertex. The next one is the middle line. It's an imaginary line that goes from the vertex to the middle of the base of the pyramid. Okay, that's called our altitude or our height. The next one is a yellow line going down the middle of one of the triangles on the sides. Okay, that's called the slant height. That's a new vocab word for us here. And we use a small cursive L for slant height, lowercase cursive L. Next one's one of the black lines around the outside. That's called a lateral edge. The next one's actually pointing to the triangle. That's called a lateral face. So for pyramids, all the lateral faces are triangles. The second from the bottom is the red dashed lines going from the center to the middle of one of those sides. You might remember this from last chapter. This is called an apothem. And finally, the one on the bottom there is pointing to just the shape at the bottom of the pyramid, and that's called our base. The base could be any shape that we know. Triangle, rectangle, in this case, Pentagon, or any other shape. The lateral area is made up of triangles. So to find the total lateral area, what do we do? Well, what we're going to do is we're going to find the area of one triangle, and then we're going to multiply that area by the number of lateral faces, the number of sides, number of triangles, if you want to say that. And then find a total surface area. All we're going to do is find the area of the base, whatever shape that is, and add it to our lateral area. So let's get started. Find a lateral area and surface area of an equilateral triangular pyramid with base side length 11 and slant height 14. So what does that mean? That means that all these sides are 11, okay? And then the slant height, which you can just draw one of those in if you want to. I'm going to draw it in here on the front side here. I'm going to make it dash because it's not a real line in our picture. Okay, that slant height is 14. It's got a right angle there. The height's always perpendicular. All right, so what we're going to do is we're going to find the area of one of those triangles. It's easy enough. The area of a triangle is just base times height over 2. So that would be 11 times 14 over 2, which is 77. And since there are 3 of those triangles, we can multiply 77 by 3, and that would be our lateral area, which is 231 square meters. Now to get our total area, we're going to take that 231 and add it to the area of the one base that we have. All right? So let's find the area of that bottom triangle. Now the area of the equilateral triangle down there, if you remember from our endeavors in the area of an equilateral triangle, the formula for that is side squared root 3 over 4. So in this case, it's 11 squared root 3 over 4. All right, the directions don't tell us how they want the answer here, so we're just going to round this to the nearest hundredth. So the area of that bottom triangle is approximately 52.39 square meters. So then finally, for our total area, we're going to take our lateral and we're going to add it to that one base. And our total area is going to be 283.39 square meters. All right, second one, we have a square pyramid now, whose base edge lengths are 9. And the slant height, if we draw a slant height in, we gotta make that dashed, is 17. All right, so then to find the area of one triangle, it's just base times height over 2. And that will give us 76.5. So then the lateral area is just 4 of those. So our lateral area is 76.5 times 4 because there's 4 of those triangles. So our lateral area is 306 square centimeters. So then for the bottom down there, the square, that's just 9 times 9, which is 81. So our total area then is our lateral plus the area of the base, 387 square centimeters. Third one, this is a little bit tougher here. We have a hexagonal pyramid. And for the first time, we aren't told the slant heights. Okay, what we're told is that the lateral edge is 10. All right, so if we draw in a slant height, we don't know it, so we'll call it L. We know that this whole side is 12, which means that these two little pieces here are 6, and hopefully right now you notice how to find L. This is a right triangle where we know 2 of the sides. We can do Pythagorean theorem on that. 6 squared plus L squared equals 10 squared. All right, working through that, we should be able to find that our slant height is 8. All right, so now I'll do the area of a triangle. So the area of a triangle here is base, which is 12, times height, which is 8, over 2. And that's 48. So our total lateral area then would be 48 times how many triangles we see here, which is 6. So our total lateral area is 288 square feet. So now we're going to do the area of the hexagon. All right, we did this a lot back in our area chapter as well. So remember, for the hexagon, we need the apothem and the perimeter. All right, so let's just write that out here. The area of the hexagon is apothem perimeter over 2. We know the perimeter because it's just 12 times 6. So our perimeter is 72. We already got that. What we don't know is the apothem. Okay? And if you remember what we need to do for this here, let's bring this triangle out. We got to do 360 over 6, which is 60, and then cut that in half to get this angle here is 30. So we know it's a 30, 60, 90 triangle, or we can just do tangent of 30 equals 6 over A. So A equals 6 over tan 30. So our apothem is approximately 10.392. So now I can go back over here. Our apothem is 10.392. Our perimeter is 72. The area of our hexagon is approximately 374.123. Add that to our lateral area. And our total area is approximately 662.12 square feet. All right, number 4, we have a pentagonal pyramid with base edge of 2 and slant height of 4. So this time they tell us the slant height, which is nice. Okay, so this is 2. And if we drew a slant height in here, That would be 4. So the area of a triangle is pretty much done for us already. Base times height over 2. That would be 4. And how many triangles do we see this time? There's 5. So our lateral area is 4 times 5. Our lateral area is 20 square centimeters. All right, now for the hard part. We got to do our pentagon. We know this is 1. We know this is A. So again, we can just bring that triangle out a little bit here. Really focus on that triangle. 360 over 5 is 72. 72 cut in half is 36. So we're going to do tangent 36 equals 1 over A. So A is 1 over tangent 36. And our apothem is approximately 1.376. So now we can do the area of the pentagon, which is apothem times perimeter. The perimeter is just 2 times 5. 5 sides of 2 over 2. And our pentagon's area is approximately 6.882. Add that to our lateral area, and our total surface area here is 26.88 square centimeters. Number 5, we're going to do a little working backwards here. The lateral area is given to us. All right, the length of each side of the base is 6. Find the slant height. All right, so the key here is that it's a pentagon. So if the lateral area is 150, and we know there's a pentagon, that means 5 sides. So the area of one triangle then would be 150 over 5, which is 30. So now I know the area is 30. Okay. So now I can set up the area of a triangle formula, which I know is base height over 2. So I know the area is 30. The base is 6. I don't know the height over 2. So that gives me 30 equals 3h. Divided by 3, we get h is 10. So my slant height, which again, we should be using L for that, is 10 centimeters. That's it for pyramids. Now let's take a look at cones. And again, we're going to start the same way we started with pyramids, by looking at the basic parts of a cone. That point at the top there, again, is called the vertex. The imaginary line going down the middle is once again called our altitude or height. The imaginary line on the side, which doesn't really exist, but if you just were to measure from the vertex to the base down the side of the cone, that would be called our slant height, which we still use cursive L for that. The imaginary red line on the circle down there is called your radius, and then the bottom circle is called our base. All right, the lateral area of a cone is a formula that we'll need to know. The formula for the lateral area of a cone is pi times the radius times the slant height. And to get from the lateral to the total, we're just going to add one base. And since the base is a circle, the area of the circle is pi r squared. So the total is going to be pi r L plus pi r squared. So number 6 is find the lateral area and surface area of the cone. This one is pretty much done for us. It's a simple substitute the numbers in the correct spot formula. So pi r L. And our lateral area is 544 pi. To get the total, we'll simply take that and add in pi r squared. And that gives us a total surface area of 800 pi square centimeters. Number 7, find the lateral area and surface area of a cone with radius 8 and height 15. All right, this one's a little bit trickier because We're given the height, not the slant height. So we have a radius of 8 and a height of 15. And we need the slant height. So once again, we can do Pythagorean theorem to get that. And our slant height is 17. And once we got that, we're pretty much good. We can go ahead right into our formulas. The lateral equals pi RL. So that would be pi RL. And the question says to keep our answers in terms of pi. So our lateral would be 136 pi square centimeters. Then for our total, we'll simply take 136 pi. We're going to add in the base, pi r squared. And our total is going to be 200 pi square centimeters. Last one says to find the surface area of the cone with base circumference 25 pi and a slant height of 3. All right, so let's draw our cone here again. We know slant height's 3, and we don't know the radius. But that's why we're told this. Circumference is 25 pi. Circumference is 2 pi r. Divide both sides by pi, we get 2r equals 25. Divide both sides by 2, we get r equals 12.5. And now we have everything we need. Remember, our formula is pi RL plus pi r squared. So pi RL plus pi r squared. All right, this one does not tell us to keep our answer in terms of pi. So we can go ahead and type everything in here to round. So 12.5 times 3 times pi plus 12.5 squared times pi. And our total area here is approximately 608.68 square inches. All right, if you did want the exact answer would be 193.75 pi. But since we're not really told which way to go with that, either one would be acceptable. That's it for surface area of cones and pyramids. We got one shape left to take a look at surface area, and that would be spheres.